Hi everyone. Today I will start to work on chapter 5, the integrals. Um, in this topic, I also want to cover the session 4.9 in all of this information below. So even though it didn't have something say like 4.9 antiderivative, but in this information below, yeah, you will handle you will have enough information to handle the 4.9 assignment in grade assignment. So you can after this you can go ahead and work on 4.9 homework. Okay, so our goal in here is we're gonna find the area under the curve, right? Give me a second. Under the curve, and when curve has physical meaning, the area under the curve also has a physical meaning. Okay, so let's take a look at the next few exercise, and we're going to use some geometry knowledge to find the area in between the function and the x-axis. So come to the exercise number 1 over here. We are having a constant function y equal to m. So in here we say function y equal to 3, and in between a equal to 1 and b equal to say a equal to 1 and b equal to 5. So we want to find the area under y equal to 3, right? And you see that this is a rectangle that have the height in here is 3 and the base in here is 4, right? So so I'm gonna say rectangle, right? And the area is it's a length times width, or so I'm gonna say base times height, which equal to 4 times 3 equal to 12. That's the answer. Okay. All right, so that's going to be the answer. Let's move to the number 2. I'm having a linear function y equal to mx plus b. Right? So, for example, in here, we are gonna try to find the area under the curve, no, under the line actually. Y equal to 3x. So in here is b equal to 0, right? On the interval from 0 to 4, right? So when you grab it, you can see the area under the curve over here is like a triangle, right triangle. Right? So if you remember the triangle area, the form of the area formula is going to be 1/2 times base and then times height. Okay, 1/2 times base times height, and then we have 1/2 times with base in here is from here to here, right? It is from 0 to 4, which is 4 in it. And then the height in here is from 0 to 12, so 12 in it. So we have 4 times 12. That's going to give you 24 as the answer. Okay. Now, let's make it complicated. We have exercise to try, number 3, a piecewise function, right? We want to find area under the graph of mx and both x-axis, where fx equal to 3 for x from 0 to 2, right? From 0 to 2. Yeah, I have y equal to 3. So here's y equal to 3, right? See that? And okay, for the x from 2 to 4, I have 5, y equal to 5, right? So here also. Okay. And then y equal to 4 if x from 4 to 6, so this one, right? All right, so what am I gonna do? I'm gonna think about use that right here. I'm gonna think about finding the 3 area. So A1, A2, and A3. 3 these area, and then adding them together, right? So so I want to add A1 plus A2 plus A3. They are all rectangular, right? All rectangles. Right? They're all rectangles. And let's find A1, right? A1 equal to how can I find A1? I have the base in here 2, the height in here is 3, right? So I have 2 times 3 equals 6, right? And I have A2, which is the base in here is from 2 to 4, so again it's 2 multiplied by the height, gonna be 5, right? Is here 5, right? See that? So oops. 2 to 5 equal to 10, and then A3 equal to 2, and I have, so here's 5, and I have here is 4, right? See that? So 2 times 4 equal to 8. So then when you add all them up, you have big A will be equal to 6 plus 10 plus 8 will be equal to 24. That's the answer. Okay. So okay, so how about I try another piecewise function in this exercise number 4 here, and I still want to find the area under the graph fx and above the x-axis, right? Where fx equal to 2 for x from 1 to 1.5. Okay, so 1 to 1.5. Okay, so I have to, I have to draw. I have to draw a line. So use a straight line. Not really straight, but So here is A1, right? And then A2 is when x from 1.5 to 2, right? So this line. Okay. So here is A2. A3 is from 2 to 4. And then A4 is from 4 to 5. Okay. So these again, these are our rectangle, right? So I just want to add A1, A2, A3, and A4 together. So A1 gonna be from 1 to 1.5 is 0.5, right? So here 0.5, 2, 2, 2. It's gonna be 1. A2 gonna be 0.5 multiplied by 4 equal to 2. A3 gonna be from 2 to 4 gonna be 2 multiplied by 3 equal to 6. And then A4 gonna be from 4 to 5 is 1 multiplied by 5 equal to 5. And then just gonna add them all up and get A equal to 1 plus 2 plus 6 plus 5 will equal to 14 as the answer. Okay. So a little bit bored for that, right? Let's try to make some. I mean, I want to let this exercise try for you guys to do. You know, it is just move up the area under the curve for y equals to 2x plus 1. Right? So we can do it. Okay, so let's move on to any general curve past the simple cases. Okay, so where example 1, so estimate the area under the parabola y equal to x squared from 0 to 1 using rectangles. So you can see in here, we want to estimate, right? We want to estimate the area under the parabola. Okay. So in here there's two cases, right? If you consider to use the right endpoint for each interval in here from 0 to 0.25, if you consider the right endpoint here, right. So here's right end point, right? So here's right endpoint, right? You consider a right endpoint to try to estimate it, right? Then you will form the right endpoint here. You will draw the horizontal line to make it become the rectangles, right? So you can see that here's one rectangle that you may later on use this to, to adding all the area and get the area under the parabola from 0 to 1. So similarly for this, from 0.25 to 0.5, you want to have a horizontal line until 0.25 and then put down here. So you're gonna now you still have another rectangles. But again, but this is like a over the line, right? It's the area actually over the line, right? So so let's move to the another area from 0.5 to 0.75. You also will get another rectangle, right? If you make the horizontal line from the right end point 0.75 and then until 0.5 here, okay, and then again these rectangles over the the area of this rectangle is over the the parabola, okay. And the last right end point is number 1. Okay, you also gonna have the horizontal line and put it down until at the actually to 0.75. And you have the last area that also over the line, over the curve, right? So our purpose is try to use this and try to use this area to estimate, right? This I'm gonna say try to use these rectangles to and add them up to get the to get an estimate for the area under the parabola. But because the area in here is over the graph, right? So we call it is like overestimate. So overestimate. Okay, so if we use right end point, we're gonna get overestimate. So in here I have area with right end point will be estimate as 104 multiplied by f of 0.25, right, plus 1/4 multiplied by f 0.5, right? In here, remember that's for f 0.25, you will get the you will get this part, right? Here's f 0.25, right? See that? And for h, for because the area, say area, say a here's a1, right? So here's a1, right? So I have a1 will be from 0 to 0.25, which is 1/4, right? Multiplied by f 0.25, something like that, right? You see that? That's the reason why I have 1.25. And then similarly, you have the area 2, area 2 over here is going to be on 4 times f of 0.5, because from 0.25 you to 0.5 is going to be 0.5. I mean, yes, f 0.5 to so we here f 0.5. Oh, sorry. Right. but for the height is still one. The base is still 1/4. Okay, so you add with another 1/4 of f of 0.75. And you know what? I'm gonna move down this one because I wanna use. Okay, so I'm gonna add 1/4 of time f 0.75, and I add with 1/4 time f of 1. Okay, so sorry, I don't know what happened. Okay, so I will have I will have factor 1/4 out. I can factor 1/4 out, and I will just use all the number for each value of f of here. So f of 0.25, what is that equal to? You're gonna multiply by, we want to square it, right? So 0.25 square, and plus with 0.5 square, and plus 0.75 square, and plus with 1 square. Okay, and then use a calculator, and you can tell me the penalty will be equal to 1.875, right? And multiply by 1/4, you're gonna get 0.4688. Okay. So this again, this is an estimate of or I should call it overestimate of the area under the parabola. Okay. Circle this. So okay. So another case that we can estimate the area under the parabola is I use the left endpoint. Okay, so I use a left endpoint for each interval. So from 0 to 0.25, I use 0 as first. Okay, and then I from 0 to 0.25, I have just line here. I see that. So then that is just 0. Area in there just 0. But anyway, just moving to the next interval from 0.25, I'm going to use this guy as the left endpoint. So from 0.25 with the y value here, I'm going to have a horizontal line to 0.5, and I get a rectangles that under the curve, and okay, under the parabola, right? Okay, so keep going with 0.5. I have another rectangle. Again, it is also under the curve, right? See that? And from 0.75 to 1, I have here, I have another rectangle. Okay. So recall it is left end point. left endpoints. And we're gonna get underestimate, underestimate. Okay. So how can we find the area for the left endpoint? AL gonna be, so the first one is 1,4 as the base multiplied by f of 0, right? See that? F of 0. And at the endpoint, see that? And plus with 1,4 as a base multiplied with the f of the left endpoint, which is 0.25. And then keep going with the next rectangle, 1/4 times f of 0.5, and keep going with 1/4 plus 1/4, right? With f 0.75, right? For the last one. So I will have equal to 1/4 times with 0 plus say 0 square, sorry, plus with 0.25 square plus with 0.5 square plus with 0.75 square. And then I will get 1/4 multiplied by 0 plus 0.0625 plus with 0.25 plus with 0.5625 equal to 1/4 use a calculator, you're going to get 0.875. And then that's going to equal to 0.2188 as answer. So you can see in here, one, this answer, the left-hand side answer over here will be over, right? We will over the real area, right? And the right answer over here is gonna be under the real area, right? From the area of the rectangles way, right? One is the right endpoint. One use a left endpoint to make the area of the rectangles. So it's, you see that how different with that, right? So the area I mean, you know, you can see it's in between 0.4688 to, I mean, in between 0.2188 to 0.4688, right? So we're gonna say true area is greater than 0.2188, right? And less than 0.4688, okay? Okay, so that is a way to estimate the area under the parallel until now using the rectangles. Okay, so you can also you can change. So you can see over here, what did I do is, if I have, you split from 0 to 1 become 4 interval, right? Right? Or 4 interval, 0. 0 to 0 0.25 and 0.5 and 0.75 and 1, right? If we change, if we make it become like split it become like 10 interval, then now what happened? You can see that the area underestimate will be 0.285. And even if I make it become 30, like split it become 30, right? You can see the area underestimate is make it bigger, become 0.3169. And for 50, for if you split become 50 interval, you're gonna get a come to 0.3234. So you can think about, oh, it going closer and closer to the real area when you split, more and more for the interval for in order to make the rectangles, right? Okay, so I'm gonna say more accurate. Say all right. So let's have some exercise to try using the right endpoint for this number 6. And I let you guys know that the answer should be 5.14. Okay, go ahead and try it. Also, exercise number 7, but in here. Okay, so for this one, we're gonna use midpoint. Okay, so maybe I gotta solve this one now. Okay, so let's say midpoint. What does that mean? Say from from 1 to 2. Okay, so the area. So estimate the area under the graph y equals square root x in between a equal to 1 and b equal to 4. So a equal to 1 and b equal to 4, right? And we want to use midpoint and 3 rectangles. Okay, so I have here and here, and we want to find this area, right? See that? We want to make 3 rectangles. So we need to split it, become 3 parts. 1 is here, 2 is here, and 3 is from 3 to 4, right? Okay. So using midpoint, what does that mean? Okay, so you want to use the midpoint of each interval in here. So 1 to 2, midpoint of that will be this point, right? And come from the midpoint, you wanna draw a vertical line to the graph. Oh, come on, man. To the graph. And then from the point that intersect with the graph, you can draw a sorry, make it better, horizontal line. Okay, and then you get it. You get the rectangle. It's here. So for this rectangle, we call like yeah, using midpoint, not left endpoint, not right endpoint. We are using midpoint for each interval. Okay. So here is midpoint. Midpoint for each interval. Right. So another midpoint gonna be here and here. Okay. So for this midpoint, you will have another rectangle. And another rectangle. Okay. Here we go. Here we go. Okay. So maybe I should draw this so clearly that we're taking the midpoint, right? Okay. So clearly you now having only 3 rectangles, okay? But the height for each rectangles here is from the midpoint of each interval, right? So the base, also the area of the midpoint will be the base for each interval is 1, right? And the height for the first interval going to be f of the midpoint from 1 to 2 is 1.5, right? And plus with 1 times f multiplied by 2.5, right? Then the second midpoint. So here I have this 1.5, yes, 2.5, and here is 3.5. Okay, so plus with 1 times f of 3.5. And then a m gonna be equal to square root of 1.5 plus square root of 2.5, because you know 1 time anything is just itself, so I don't want to need 1 anymore. 3.5, and then use a calculator, you will get 4.6767. Okay. Okay, so that is about using midpoint. Okay. So now that you understand that the basic principle, we are free to start using technologies, and then computer are great at doing the calculation needed to estimate the area under the curve A. Okay, so now let's we go ahead and use the GeoGebra apps for doing all this busy work. So let's say come back with say, let's see example number 1 here with y equal to x squared. Okay, so say y equal to x squared. So after you click on that, you're gonna have to change this as if x equals to x squared here, and then let's see, from where to where? From 0 to 1, right? 0 to 1. 0 to 1. So let me see. So we want to, here's what endpoint. Okay, let me see. So I really want to make how many? I want to check this. Oh, here. Okay. So how many do I have? 1, 2, 3, 4, 4 interval, right? So change n to be 4 interval only. Okay. And then I want to have the right end part first. The right end part. So the right end part is here. It is 0.377 37745, right? Oh wait, sorry, so this graph is, let me see. Okay. So if I use the upper sum, it means the right hand part will be 0.530, right? Didn't have a good number, correct number, let me see. So look like I think they have a different number with us. So for this one, I would not use that for now. I will come back with it later whenever I have understand these apps. So for now, just skip it. Okay. It's mostly the way in here is okay on my lecture here. So for the for the apps, maybe I have to understand what does it do first. Let's see what happened. Okay, so let's come back with the notes and keep talking about the area under the curve with using Riemann sum. Okay, so firstly, let's talk about the sigma notation. Okay, so say we have sum with a large number of terms, say 1 plus 2 plus 3 and plus until 100. So you're gonna think about the sigma notation provide in a shorthand way of writing is over here as sigma. Oops. Sigma of k. That's k from 1 to 100. Right. So that's going to be 1 plus 2 plus 3 plus da 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 plus 100. Because in here, I want to substitute k from the value from 1 to 100 and adding of the. So this sigma is mean sum. So we say that sum from k equal to 1 to k equal to 100 of k. And then we call k, we call here is as k is called the index of summation. Okay, So in both here. Now we're gonna try to do the example number 2 by expand the sigma notation here. So we have k squared plus the summation k from 1 to 5 of k squared plus 2k. I'm gonna change. I'm gonna have that expanded become 1 square for the first value. Right? Let me see. Oh, come on. 1 square plus 2 times 1. That's for the first number, and then I plus with second one as 2 square plus 2 times 2. Right, but k is 2, right? And then plus with 3 square plus 2 times 3. And I keep going until, well, I even still have 4 and 5 only, so I just wanna just adding with 4 square plus 2 times 4, right? And I adding with 5 square plus 2 times 5, right? That will be 3 plus 8 plus 15 plus 24 and plus 35. And then finally you have had 85 as the answer of this summation. Okay, so let's do more generally for if f of x is a function, and then we want to find the summation of fk, when k is from 1 to n. So what we have is in here is f of 1, because the place start with 1 first, right? Adding with f of 2, adding with f of 3, and adding with until f of n. See that? So what is useful in here? We have sigma notation allows us to have the flexibility of changing the function being used with f of x, right? B, the flexibility to adjust the number of terms evaluated by adjusting the upper index n. And C, it's easier to encode a sum in the format Python, Java, C++, or something else. Okay, so I will let you guys to work on exercise triangle A and number 9 also. Okay. Now we're gonna talk about Riemann sums. We call like positive functions. Okay. So suppose that f of x is a continuous function with domain from A to B over here. Okay, domain is from A to B. Okay. And based on our previous work, the area under the graph y equals to Rx can be approximated with sum of area of the rectangles, and this requires 4 steps. In here, I want you to keep in mind that the distance between the xi and xi plus 1. Okay, the next other like the consecutive x will be delta x. Okay, so step 1, figure out the width. Okay, so width is width of the sub-intervals. Or I can say the sub-interval of width. Okay. So suppose the number of rectangles in N, we partition the interval A to B into N equal sub-intervals of width. So we, in order to find this width, we're gonna, there's an x, it's gonna take B minus A and divide by N. And then we're gonna have equal sub-intervals width. Right, so this can use to the picture down here. Delta x gonna be for each of this interval width. I see that they equal each other. So okay. So with x0 equal to A and xn equal to B. So this is the width of each rectangle. Later, I see that. Okay. And step 2, you're gonna figure out the height. You must decide how to choose the height of the approximating rectangles. There are 3 standard choice. First, left and part. So you can say here is x. You know what? Let me use this. Let me clean this up. Okay. So here is x I, and here is xi plus 1. And then I have here is line. Okay. Okay. So I'm gonna use the left end point, is the left point and the left end part of the interval. It's xi here, and make the rectangle. Make the height of the rectangle. Okay, so here we go. So use this as a fxi. It's going to be the height. If I use the midpoint, so then say xi here and xi plus 1 should be here. And then the midpoint of it will make the height of the rectangle, and at that the height is going to be f of xi plus xi plus 1 divided by 2. Okay, so then the right end point, now I come to the right end point. Say here is xi plus 1, and here's xi. And then the right end point is going to be here. We have f of x plus 1, xi plus 1. Okay. Okay, so for purpose of the discussion, let's choose left endpoint. And then we can adjust, sorry, you can adjust the discussion below so that it applies to the right endpoint or midpoints. Okay, so we have f step 3 going to be on each interval x I plus 1 to x okay. The area of rectangles is given by a plus 1 equal to f xi multiplied by delta x. So let's use the left endpoint. Let's choose the left endpoint. Okay, so let's see what happens. So here is the graph. Okay, here is graph x y here. Here is a, here is b, here is x1, x2, x3, dot dot dot, xi, and then x I plus 1, and dot 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 to p, right? So if I use a left endpoint, okay, wait a second, let me draw the graph first. If I use the left endpoint, then let's start with a here, first endpoint, and make the first rectangle here, right? And this is a1, and x1 here we make the second area or second rectangles as a2, and x2 here gonna be the third left endpoint. We make a3, and I keep going. Say, oh, sorry. Oh my goodness. Hmm. So I have this, okay. And then, okay, so now I change this to be, so I have a4, I mean, this guy, somewhere here, okay, a4. And keep going with that. And I have x I to x I plus 1 here. Here is x, a something. Okay, so keep going until the last one should be here to here. Okay. Not very clear for that, but anyway, so that's still a left endpoint. Okay, so use as a color for the pen. I have f x I will be the height of rectangle, right? Rectangle. Position, right. And you might take it out. You can see that, say this one is a of I plus 1, something like that. Then the area of a plus 1 it is xi, and it is f of xi. That will be xi plus 1 in between the, so we get x. Is width of rectangle. Okay. See. So then the area here going to be delta x multiplied by here. Here is delta x. So here is delta x. Right? The distance between xi and xi plus 1 going to be delta x. And the height is going to be fxi. So the area should be, should be fxi times delta x. The last one, step 4, you're going to call Ln, or we will stand for the left endpoint. The sum of the area of these rectangles. So you're going to have Ln equal to fx0 times the x plus fx1 times the x and plus dot 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 plus fxn minus 1 times the x, which is equal to a1 plus a2 plus dot dot plus an. Okay, so the definition. Let fx be the continuous function defined on a to b, and n be the positive integer. Then we say Ln is the n left Riemann sum of L. N is given by fx0 delta x plus fx1 delta x plus fxn minus 1 delta x, will equal to fxi times delta x. Okay. For the n right Riemann sum, it's gonna be same thing, but now it's gonna be sum from I equal to 1 to n of fxi delta x. Right? Because now so you're using the right the right endpoint. So in here you're gonna have start with fx1. So I think in here you should not be using this one. We should not have that one. We should start with this guy to n. So this is typo. Okay. And And C, if we choose the midpoint for xr to xi plus 1, we can define mn as n midpoint, remain sum of f and given by, say, f of x0 plus x1 divided by 2 and multiply by the other x. So keep going like that until the last term is f of xn minus 2 plus f xn minus 1 over 2 multiplied by the other x. And that's going to be equal to summation of f of xi plus xi plus 1 over 2 multiplied by the other x for I equals to 1 to n. Okay. So I would love to say stop for this video here, and we'll come to the next part later. So let's stop it here and see you later.